Hey there, mathematicians. Today we are going to talk about adding and subtracting fractions. In case you don't have your notes with you, I'm going to put the adding and subtracting rules up on the screen real quick. They are very similar, with the subtracting rules having a little bit extra to tell you how to deal with borrowing. Here they are, take a look. I do hope that those rules are going to be helpful to you. We are going to go through those rules with each of the next two problems straight off our homework together. I'm going to talk you through them, and we're going to see exactly how these should be solved. Hopefully that's going to be enough information so that you, yes you, can go ahead and finish this homework and feel confident about it because you followed all of the rules. Hi there, mathematicians. Let's start by going over number 10. For number 10, we've got two nice fractions, 8 and 4/7 minus 7 and 5/7. I'm going to take a look at our notes, and I'm going to go through those step by step. The first step on our notes says that we need to find a common denominator. One of the nice things about number 10 is that we already have a common denominator. So we don't have to find one, we will have to in the next problem. So I'm going to go then to our next step, and that is to, subtract the numerators. That is a problem. You see, we have 5 being subtracted from 4. We're subtracting more than we have. We are going to need then to borrow. Let's go look at the 8. We're going to borrow from the 8. We're going to borrow a whole number from the 8. It's going to become a 7, and we are going to add that whole number to our fraction. But to add that whole number to the fraction, we've got to make it have a common denominator as well. We are going to write one whole as 7s. There we go. One whole is equal to 7 out of 7. Now we can add these. When we add them, we get 11 sevens. Now we can subtract. Now we have a big enough number to subtract. Bring that 5 over. 11 sevens, subtracting 5 sevens, leaves us with 6 sevens. Then we got to subtract the whole numbers. 7 minus 7 is 0. My answer is just 6 sevens. All right, you smarty pants. Let's move all the way down to problem number 22. Problem number 22 asks us to find the perimeter of this figure. I have gone ahead and listed the 3 sides that we are going to add up to find the distance around it, or the perimeter. Here they are. Aren't they beautiful? The only problem here is that these have different denominators. And our first step on our notes for adding fractions is to find a common denominator. The common denominator we're going to use for this problem is 12ths. So I'm going to rewrite each one of my fractions to be 12ths. To do that, look at the denominators. I have to multiply 2 by 6 to get 12. So I must multiply 1 by 6 as well. And 1/2 becomes 6/12. 3 times 4 is 12, so 2 times 4 will get us 8. 2/3 is 8/12. 3/4 we multiply by 3, and 3 times 3 is 9. Now I can add the fractions that we have. I'm going to add up 6 and 8 and 9 to get 23/12. Denominator, of course, stays the same. After we've done that, we are then going to add up our whole numbers and get 15. This is great, but unfortunately, we have an improper fraction. Improper fractions need to be changed so that we can write it as a normal mixed number. We want to be proper. To do that, we are actually going to divide the numerator by the denominator. I'm going to go ahead and write 23 divided by 12. 12 will only go into 23 one time. One whole time. In a minute, we're going to take that whole and we're going to add it to the 15. But when I subtract that 12, like we typically do with division, we're going to have left over 11. And leftover is exactly the right terminology to use. When we take out a whole number, we're going to have 11 left over. The denominator of our fraction will not change. We're going to take that whole, add it to 15, and get 16, and we are going to leave the 11 over 12. So 16 and 11 twelfths is our answer. Oh, they got me. Oh, where are they? I'll give them what, 4?